Okay. So as you're writing those down, I'm going to write a couple things up here just to show you how some of this works. Let's just look at the first one. This is 7.2 fundamental trig identities. Okay? Let's look at the sign for this one. The sine of s plus t is the same thing as the sine of s. The cosine of t plus the cosine of s sine of t. Why we use s and t. And this is fairly simple to do. So I'm just going to do an example with this first one. I'm not going to go through every one of them, just to kind of show you how the beginning part of this happens. Then I'll give you, part of the assignment for today. You can work through it. But you need to use all of these that you have on your identity chart and figure out how to do this. So if I said the sine of 75 degrees, I can break that apart into something like this. I don't know what the sine of 75 degrees is, but I can definitely break it apart into something I know. I know the sine of 60 and 15. No, I don't know 15, do I? I know 60. What about 40 and 35? I don't know either one of those. Can you think of two angles that we do know the values of that we can break apart 75? 45 and 30, we have a winner. 45 and 30. We do know these values. So now you just plug these into the positions. So the sine of 45 degrees times the cosine of 30 degrees plus the cosine of 45 times the sine of 30. And you should know what each of those are. The sine of 40, again, this is where the unit circle comes into play. What's the sine of 45? What's the y value of 45 degrees? Radical 2 over 2. What's the cosine? The x value at 30 degrees. What? Yeah, radical 3 over 2. What's the x value at 45 degrees? Okay, and the y value at 30 degrees? 1/2. Look at what we get. This is the square root of 6 over 4. This is the square root of 2 over 4. So my answer is radical 6 plus radical 2 all over 4. That's it. So I'm sure you're sitting there going, well, why don't I just take my calculator and take the sine of 75 degrees? That's not the point. For the same reason we do geometry and algebra 1 where we leave things in radical form and we work things down. It's what we're doing behind this. It's how things are solved and how you can break apart. Making your brain think that you can manipulate this. Again, remember, this is manipulation. Changing the way it looks to make it so we can do something else with it. We can't do any application until we can do these things. Alright? So this is all about what the identities are like, okay? Let's do another one. I'll erase this one and we'll do a different one. Okay? Let's pick, let's see, what do I have up here? Let's do a cosine one, I guess. Let's do cosine, so this is cosine of s, let's do s minus t. If I can find one like this. So the cosine of s times the cosine of t, and this will be a plus sine of s, sine of t. Okay? Alright, again, now you see why we want this on our cheat sheets, because there are a lot of different combinations, right? Daniel, knock it off. Alright, so, how about the cosine of 195 degrees? Now that you kind of got this, what do I know, what angles do I know that I can break this apart into subtraction to get 195? So if you need your unit circle, I can get it out. Okay? What do you thing. I'll wait for you. I mean, this is subtraction. Come up with angles that you can solve on your unit circle. That you can, two angles that you know of that you can subtract to get 195.
$135
and 60, that's if you add them. I want you to subtract. I want two. So you need a big angle.
225 and 30.
What?
225 and 30.
225 minus 30?
Yeah.
Does everybody agree? 225 minus 30. Okay. What is the x value at 225 degrees? Oops, I'm sorry. So the cosine of 225, cosine of 30. What's the sine of 225? And the sine of 30. What's the x value at 225? This is why you gotta know this stuff. It's a 45-degree angle. Negative radical 2 over 2. You're in the third quadrant. What's the x value at 30 degrees? Alright, 3 over 2, thank you. What's the y value at that 45-degree reference angle? Negative radical 2 over 2. And the y value at 30? 1/2. Are we catching on? How to do this? Okay. So this is negative radical 6 over 4 plus negative radical 2 over 4. So basically, the book I think writes it like this. I don't care how you write it, okay? Or negative 1/4 times radical 6 plus the radical 2. I don't care. Just put them together over one denominator. You could write negative 6 minus radical 2 over 4 if you want. That's fine. All right, so this is kind of what you're doing. I'm not going to do a tangent one. You have that there. So all it is figuring out which angles to use, right? How to either add two angles together or subtract two angles that you know of on your unit circle. That's what the beginning part of this is about. All right, so this is going to be your assignment. Let's do page number here. No, I don't. What page is that, Jen? Oh, I got it right here. I got it. Page 505. I want you to do 4 through 20 evens. Do you really need the odds? No. I mean, you gotta figure the angles out. Now, look, on 15 through 20, 16, 18, and 20, you're given this, and it asks you what the answer was. So you're going to work it backwards. That's all. And if you need to look at an odd one to see how they did it, then look at an odd one. That's fine. All right, so that's your assignment. Tomorrow we're going to continue with this section 2.